In late 2024, a major fintech gateway experienced a catastrophic $1.2 million loss in a single afternoon. The post-mortem report revealed a chilling cause. A senior developer, pressured by tight deadlines, merged over 10,000 lines of AI-generated code without sufficient architectural verification. The AI had hallucinated a non-existent parameter in a critical transaction API, leading to a silent failure in idempotent logic. While the code passed basic unit tests, it failed to account for high concurrency race conditions and nuanced edge case the AI simply ignored. This incident serves as a stark warning for 2026. High-speed coding is no longer an asset. It is a liability when it bypasses the fundamental principles of software engineering like the ISO IEC 27010 quality standards. In this era, the more code you produce without judgment, the more technical debt you manufacture. We are entering a phase where the illusion of productivity can become a terminal threat to corporate stability. Speed wasn't the solution, it was the catalyst for catastrophe, and the reason behind this failure will redefine your entire career trajectory by the end of this lecture. By 2026, the industry definition of a senior developer has fundamentally shifted. We have moved from software 2.0, where developers wrote the logic, to software 3.0, where developers must curate the logic. The primary value proposition of an engineer is no longer how fast can you write this function, but rather should this function exist at all, and is this specific implementation the most resilient? This is the transition from a code writer to a technical curator. As a curator, your ability to discern high-quality, maintainable, and secure architecture from a pile of mediocre AI suggestions becomes your only moat against automation. Without this judgment, you are merely an expensive interface for an LLM. In the professional world, we refer to this as systemic judgment. It's the difference between a junior who accepts the first prompt result and a master who refines it against real-world constraints. Is this transition merely a choice, or is it an inevitable survival mechanism? Let's look at the actual roadmap that separates the survivors from the replaced. This lecture isn't about learning a new framework or a prompt engineering trick. It is about building a systematic framework for taste. Many developers think taste is a subjective gut feeling, but in professional engineering, it is a quantifiable set of decisions based on scalability, readability, and cognitive load. Over the next hour, we will transform your intuition into a rigorous judgment framework. We will analyze real-world case studies where good-looking code was actually a disaster and where ugly code was an architectural masterpiece. We will cover the 10x value extraction process, how to use AI to generate 10 VAN variations and use your judgment to pick the one that won't break at 3 a.m. on a Friday. We will move through 3 stages: defining taste, applying judgment to code review, and finally, career positioning for the 2026 market. The theory sounds solid, but the industry's timeline of what actually matters in a hire is shifting faster than most realize. Let's see where you stand on that timeline. To understand where we are going, we must look at where we have been. 2020, the market rewarded syntax mastery, knowing the quirks of JavaScript or the nuances of Java's memory model. By 2024, the focus shifted to AI prompting, the ability to interact with LLMs to accelerate development. But by 2026, these skills have become commoditized. When everyone can generate code, the only scarcity is system judgment. Hiring managers are no longer looking for developers who can solve leak code problems in 10 minutes. They're looking for architects who can explain why a specific AI-generated solution is wrong for a distributed system. The focus has moved from the how of coding to the why of engineering. If you are still competing on coding speed, you are competing with a tool that is free and infinite. To truly dominate this new market, we first need to define the most elusive word in software engineering: taste. We'll decode exactly what that means and why it's your new competitive edge in the next chapter. In the software 3.0 era, taste is no longer a vague, artistic preference, but a critical engineering metric. As AI models like GPT-4 or Claude 3.5 Sonnet can generate thousands of syntactically correct solutions for a single prompt, the developer's role shifts from creator to curator. Taste is the technical judgment used to choose the most sustainable, scalable, and maintainable path among infinite AI-generated options. Think of it as an internal compass aligned with ISO IEC 27010 software quality standards. While AI prioritizes immediate functionality, a developer with taste prioritizes long-term system health. It is the ability to recognize which code patterns will survive a sudden change in business requirements and which will become technical debt by next quarter. This judgment is what separates a typist from an architect. But how does this abstract concept manifest in actual code? Let's look at a concrete comparison that highlights the cognitive load difference between raw AI output and high-taste engineering. Let's compare 2 approaches to solving the same problem: an AI-generated correct snippet and a tasteful snippet. On the left, the AI provides a highly nested, imperative solution that handles all edge cases, but introduces massive cognitive load. It works, but it's brittle. On the right, a developer with taste has refactored that suggestion into a declarative, modular structure using early returns and functional composition. The correct code is a black box that requires 20 minutes to audit. The tasteful code is self-documenting and can be understood in seconds. In 2026, the cost of software isn't in the writing, it's in the reading and the cognitive energy required to maintain it. High-taste developers minimize this cost by enforcing simplicity over cleverness. They understand that AI often hallucinates complexity to appear smart. The question then becomes, where does this taste fit within the actual technology stack of the future? This leads us to the unique structure of the Software 3.0 stack, where the rules of logic have fundamentally changed. In the Software 3.0 era, we are dealing with a hybrid stack. At the base, we have the probabilistic layer, LLMs and neural networks that generate logic based on patterns rather than rigid rules. This layer is non-deterministic. However, the architecture surrounding it, the integrations, the data schemas, and the security boundaries must remain strictly deterministic. Taste is the glue that connects these two. It's the ability to wrap a fuzzy AI output in a rigid, reliable architectural shell. Experienced developers know that you cannot build a skyscraper on a swamp without a solid foundation. They use their taste to define where the AI's probabilistic nature is acceptable and where traditional, deterministic rigor is mandatory. If you treat the entire stack as probabilistic, your system will collapse under the weight of its own unpredictability. Now that we understand the anatomy of taste, how does this translate into real-world productivity? You might be surprised to see how the gap between fast coders and tasteful engineers is actually widening in the AI era. There is a myth that AI levels the playing field for all developers. In reality, it amplifies existing skill gaps. An engineer without taste becomes a copy-paste architect, rapidly accumulating technical debt that will eventually bring their productivity to zero. Conversely, an engineer with taste uses AI as a high-speed engine, but they keep their hand firmly on the steering wheel. We call this the productivity delta. In the field, we observe that fast developers who lack taste initially look productive, but their velocity drops exponentially as the codebase becomes unmanageable. The 30x engineer isn't 30 times faster at typing. They are 30 times more effective because they only accept code that contributes to the system's longevity. They spend more time thinking than generating. Let's look at the actual metrics of how these two types of developers diverge over a 6-month project cycle. It's the difference between a system that evolves and a system that rots. But how do they actually achieve this filtering in their daily workflow? The workflow of a 10x or 30x engineer in the AI age is a rigorous feedback loop. It starts with a precise prompt, but that's the easiest part. The real work begins when the AI returns its suggestions. A tasteful engineer performs an immediate architectural audit. Does this follow the single responsibility principle? Does it introduce unnecessary dependencies? Instead of clicking apply, they iterate. They might reject 80% of what the AI provides, asking for specific refactorings like extract this into a pure function or simplify this conditional logic to reduce cyclomatic complexity. This filtering process is where the value is created. It's a continuous cycle of prompting, auditing, rejecting, and refining. This ensures that the final code isn't just working code, it's engineered code. By the time the code is merged, it has been through a human-led quality gate that no current AI can replicate. This leads us to a fundamental shift in how we define a senior developer. In the past, it was about what you could build. Now it's about something entirely different. As we move toward 2026, the definition of seniority is being rewritten. Historically, a senior developer was the one who could write the most code or solve the hardest bugs. Today, seniority is measured by the quality of what you reject. An AI can write 1,000,000 lines of code in a day, but it cannot decide no to write them. A senior developer with taste knows when a feature should not be implemented, when a library should not be added, and when an AI suggestion is a trap. They act as the editor-in-chief of the codebase. This shift from constructor to decision maker is the core of the new technical career path. To thrive, you must stop worrying about your typing speed and start focusing on your judgment framework. We have defined taste as the ultimate competitive advantage, but how do we turn this abstract taste into a systematic, repeatable skill? In the next chapter, we will break down the systematic classification of technical judgment, providing you with a framework to build and prove your taste in any project. Stay tuned to learn how to categorize your decisions like a professional strategist. In the Software 3.0 era, technical taste is no longer a vague aesthetic preference. It is a multidimensional construct that can be classified into 4 distinct pillars. These pillars align with ISO CEC FESTAO FEDS 10 standards, but add a layer of practical intuition. First is simplicity, the ability to minimize cognitive load while maximizing functionality. Second is context awareness, which involves understanding the specific infrastructure and team constraints. Third is future-proofing, which isn't about over-engineering, but about ensuring modularity for inevitable change. Finally, user centricity ensures that technical decisions prioritize performance and accessibility. Understanding these pillars allows a developer to audit any solution, whether human or AI-generated, with structural rigor. But how do these pillars manifest across the different levels of our daily work? Let's move from theory to the actual architecture stack. Technical taste must scale across the entire software hierarchy. At the code layer, taste is reflected in naming conventions and local logic flow, often where AI excels. However, as we move up to the module layer, taste involves applying solid principles to manage dependencies. At the system architecture level, judgment becomes critical. It's where we decide between a monolithic approach for speed or microservices for scale. Finally, at the product level, technical taste is the ultimate alignment between technology capabilities and business objectives. A senior developer's value lies in maintaining consistency across these layers, ensuring that a decision made at the system level doesn't create unmanageable complexity at the code level. In every layer, we face choices where there is no single right answer, only trade-offs. What are the specific dilemmas that separate a senior's judgment from an AI's suggestion? In the field, we rarely choose between good and bad. We choose between two goods with different costs. This is the essence of architectural trade-offs. For example, an AI might suggest a globally distributed database for a new app because it's a best practice. However, a developer with taste recognizes that for a localized MVP, the latency of a single region setup is a better trade-off than the complexity of multi-region consistency. We must balance consistency vs performance, flexibility vs complexity, and development speed vs long-term technical debt. These decisions require a deep understanding of the specific project's lifecycle and risk profile, something data-driven models often miss by prioritizing popular patterns over specific needs. This decision-making process feels intuitive to experts, but we can actually systematize it into a mental checklist to audit any architectural proposal. To effectively manage AI-generated architectural proposals, we need a rigorous evaluation framework. I recommend a 5-point checklist for every significant code block or system design AI provides. First, check for YAGNI compliance. Is the AI adding features you won't need? Second, evaluate deletability. If this requirement changes, how hard is it to remove this code? Third, assess the observability. Does this design allow us to monitor its health in production? Fourth, check for dependency health. Are we introducing unnecessary third-party risk? And finally, consider team cognition. Can a junior developer understand this logic at 2 a.m.? High-quality judgment means asking these questions before the code is merged. Now that we have a framework for judgment, we must address the fundamental reason why AI cannot replace this skill: its inherent blind spots in high-level reasoning. AI operates on patterns, while human developers operate on context. This is the context gap. AI lacks two critical things: business strategic awareness and long-term ownership sentiment. For example, if your company is planning to migrate from AWS to on-premise in 6 months, an AI trained on AWS-heavy public data will consistently suggest AWS-native services that would make that migration a nightmare. An AI cannot feel the pain of a 3 a.m. production outage caused by its own complex code. Therefore, it doesn't prioritize boring but reliable solutions. Humans weigh the total cost of ownership, including the ease of hiring developers who can maintain the stack. AI optimizes for the snippet. You optimize for the decade. Beyond missing context, AI often falls into the trap of over-patterning, applying the most popular solution even when it's completely overkill. A major technical flaw in AI-generated code is pattern overfitting. Because LLMs are trained on vast datasets like GitHub, they gravitate toward the most frequently occurring architectural styles. This results in the everything is in nails syndrome. For instance, an AI might generate a complex Redux Saga implementation for a simple contact form just because Redux is a high-frequency pattern in its training data. This leads to resume-driven development by proxy, creating massive over-engineering in simple projects. A human with taste knows that a simple use state is better for a form, even if the world's most popular repositories use Redux. Your job is to prevent AI from turning your lean codebase into a bloated museum of popular but inappropriate frameworks. If AI provides the what, the boilerplate, and the common patterns, then what is the why that only you can provide? To wrap up this classification of technical judgment, remember this fundamental distinction: AI provides the what, but humans provide the why. We've explored the 4 pillars: simplicity, context, future-proofing, and user-centricity, and how they must be applied across the entire architecture stack. We've seen how AI's blind spots in business context and its tendency to over-engineer through pattern overfitting make human taste a premium asset in 2026. In the current market, the developer who has the guts and the logic to say no to an AI's complex suggestion is more valuable than the one who can write 10,000 lines of code an hour. We've classified what judgment is. Now, how do we actually build it? In the next chapter, we'll dive into the engine of excellence, the specific methods for training your technical intuition through deliberate practice and systematic review. In the AI era, the bottleneck is no longer how fast you can write code, but the quality of the inner model you use to evaluate it. If your primary source of learning is mediocre tutorials or Stack Overflow snippets, your technical taste will be capped at a mediocre level. To cultivate high-tier judgment, you must practice curated consumption. This means moving beyond the what and diving into the how of world-class engineering. Study the Linux kernel's memory management to understand resource constraints, or analyze the React Fiber architecture to see how complex state reconciliation is handled at scale. By exposing yourself to production-grade, battle-tested codebases, you calibrate your internal compass to recognize what optimal truly looks like. Industry standards like ISO/ISC 25010 provide a framework for these quality attributes, but true taste is the intuitive application of these standards in real time. Question: but even with great input, how do you handle the flood of mediocre code AI produces every second? Let's look at a real code review scenario. Let's examine a typical AI-generated pull request. The AI might suggest a working solution for a data-fetching hook, but a taste-focused review looks deeper. Notice here how the AI prioritizes brevity over maintainability. It creates a tightly coupled dependency between the UI component and the API structure. A developer with high taste identifies this leaky abstraction immediately. They don't just ask, does it run? They ask, is this scalable? How will this handle a 503 error? Is the state logic becoming a tangled mess? By focusing on decoupling and clear interfaces, you transform a fragile snippet into a robust architectural component. This is where your value lies, being the human filter that prevents technical debt from accumulating through automated generation. You are no longer checking for semicolons. You are checking for structural integrity. Payoff, the difference is subtle but vital. Let's see the transformative power of refactoring when taste is applied to AI-generated debt. Observe this before stated is a big ball of mud generated by a large language model. While it works for a simple use case, it collapses under real-world pressure. It mixes business logic with infrastructure concerns, making it nearly impossible to unit test. Now, look at the after version refactored by an engineer with high taste. We introduce a repository pattern to abstract data access and use a state machine to handle loading, error, and success states deterministically. The code didn't just get cleaner, it became strategic. It respects the future needs of the project. This level of refactoring is what separates a prompt engineer from a software architect. Use the AI's speed to get the raw material, but your taste provides the final, durable form. Teaser refactoring is the external symptom, but the internal root is something much deeper, returning to the very laws of physics in software. As LMs become more pervasive, we must remember that they operate on probability, not logic. They predict the next most likely token, which often leads to average solutions. To transcend this, you must return to first principles. When evaluating a distributed system, don't just rely on what the AI suggests. Apply the CAP theorem, understand the fallacies of distributed computing, and evaluate trade-offs between consistency and availability based on your business domain. Principles like SOLIDRY and KISS are not just academic buzzwords, they are the constraints of software physics. In 2026, the developers who thrive will be those who can audit AI outputs through the lens of these fundamental truths. Your competitive advantage is your ability to say no to a probabilistic suggestion because it violates a deterministic principle. Question: once we have this judgment, how do we define our role in the team? Are we just fast coders or something more? The first identity in our 2026 framework is the builder. In an AI-augmented world, the builder is characterized by extreme velocity. Their primary goal is to close the gap between an idea and a shipped product. They treat AI as a force multiplier, using it to automate boilerplate, generate scaffolding, and prototype features at a speed that was impossible 5 years ago. The builder's mindset is centered on maximum value surface area, shipping more, testing more in the market, and iterating quickly. However, velocity alone is dangerous. Without a counterweight, the builder risks creating a legacy of unmaintainable garbage. The builder is the go in the system, but every high-performance engine needs more than just acceleration. Question: if everyone can build fast with AI, what prevents the entire system from collapsing under its own weight? Enter the craftsman. The second identity is the craftsman. While the builder moves fast, the craftsman ensures the system is durable. This is where the judgment we've discussed becomes a tangible asset. The craftsman is obsessed with quality, stability, and the long-term health of the codebase. They use AI not to code faster, but to find edge cases, simulate complex failure modes, and improve documentation. They apply the concepts of software craftsmanship to ensure that what is built today doesn't become the roadblock of tomorrow. In many ways, the craftsman acts as the brakes, ensuring that the speed of the builder doesn't lead to a catastrophic crash. They prioritize the sustainability of the software, making decisions that favor clarity over cleverness. Payoff. In the past, these were often two different people. In 2026, you must be both a duality we call the hybrid model. The elite developer archetype for 2026 is the builder craftsman. This hybrid model is a synthesis of speed and stability. You use AI to achieve 10x velocity, the builder, but you filter every line through your refined technical judgment, the craftsman. This creates sustainable speed. It's the ability to build an MVP in a week that is also architecturally sound enough to scale to 1 million users. You are no longer just a coder, you are a strategic decision maker. You know when to cut corners to validate a hypothesis, and when to build a fortress to protect the core business. This dual threat capability is what will command the highest premiums in the labor market. Bridge: now that we've defined the mindset and the identity, how do you actually map your career to this new reality? In the next chapter, we'll build your 2026 career roadmap. By 2026, the market will be saturated with AI-augmented developers who can churn out code at lightning speed. However, speed has become a commodity, driving the economic value of pure implementation towards zero. To survive, you must reallocate your learning capital from commoditized skills to AI-resistant ones. AI excels at syntax, unit test generation, and boilerplate, but it struggles with what I call software entropy management. This involves understanding the long-term maintenance costs of a specific architectural choice or aligning technical debt with business cycles. We must look at the ISO/ISC 25010 software quality model not as a checklist, but as a strategic map for human judgment. While AI can optimize a single function, a human expert must evaluate if that optimization compromises the system's modularity or future scalability. You are no longer a coder, you are a quality and risk orchestrator. But how do we structure these shifting skills into a personal growth framework that recruiters actually value? Teaser: the answer lies in a fundamental redesign of the classic career model, the T-shaped developer. In the previous era, the T-shaped developer had a broad base of general knowledge and one deep vertical of technical expertise, like React or Go. In the 2026 landscape, the horizontal bar of the T is now AI orchestration. This means you don't just use AI, you build agentic workflows, manage LM context windows, and verify AI outputs with surgical precision. The vertical bar, however, has shifted from implementation speed to technical taste. This vertical is built on 3 layers. First, conceptual integrity, ensuring every part of the system follows a unified philosophy. Second, domain deep dive, understanding business constraints like financial regulations or low latency requirements better than the AI ever could. Third, critical skepticism, the ability to reject a technically correct but contextually wrong AI suggestion. This new model ensures that while AI provides the breadth, your taste provides the depth that prevents system collapse. Question, but how do you demonstrate this abstract taste during a high-pressure job interview when everyone else is also using AI to solve leak code problems? The hiring landscape is undergoing a radical shift. Recruiters are realizing that solving a leak code hard problem in 5 minutes is no longer a signal of intelligence, but a signal of a good AI subscription. In 2026, taste is the new technical bar. Your portfolio should no longer be a list of finished features, but a decision journal. When asked about a project, don't focus on the stack. Focus on why you rejected certain patterns. For example, I chose eventual consistency over strong consistency despite the AI's suggestion because our business model prioritizes availability over real-time accuracy during peak loads. Show your taste through your code reviews demonstrate how you catch subtle design flaws that AI misses. Interviews will move towards system evolution scenarios. Here is an AI-generated architecture. Tell me why it will fail in 6 months. You must prove you are the pilot, not just a passenger. Payoff, this transition isn't just about surviving. It's about moving from being a feature implementer to a decision owner. To conclude this roadmap, let's summarize the transition. The era of the high-speed implementer is closing, and the era of the strategic technical owner is beginning. Your value in 2026 is determined by 3 factors: your ability to orchestrate AI for maximum output, your depth in domain-specific constraints, and your developed taste for clean, maintainable systems. Moving forward, you should spend 20% of your time mastering new AI tools and 80% of your time deepening your understanding of fundamental principles like the CAP theorem, distributed system patterns, and domain-driven design. Remember, in a world where everyone can produce code, the one who can decide which code should exist is the one who leads. You are evolving from a worker who does to an expert who decides. Bridge now that we have the roadmap. Let's wrap up this journey. In the final chapter, we will see why taste isn't just a career skill, it's the ultimate competitive edge for the future of human-AI collaboration. In the final analysis, we must recognize that the era of manual labor coding is being replaced by architectural orchestration. Throughout this series, we have observed how AI can generate thousands of lines of code in seconds, making high coding speed a commodity rather than a competitive advantage. According to industry quality frameworks like ISO IEC 25010, software quality is a multidimensional construct, including maintainability, portability, and reliability. AI can optimize for a single metric, but it lacks the taste to balance these conflicting priorities within a specific business context. Your role has shifted from being a builder to a curator of excellence. You must now possess the discernment to reject a technically functional solution that lacks architectural elegance or long-term sustainability. This is where your competitive edge lies, in the selective refinement and strategic filtering of machine-generated output. But wait, is this taste purely subjective, or can it be measured by the systematic impact we leave on the codebase? Let's finalize our vision for the next decade. Looking toward 2026 and beyond, the distinction between a coder and a true engineer will be defined by the ability to apply subjective judgment to objective automated data. In a world of infinite code, the scarcest resource is not the code itself, but the decision-making that governs its deployment and evolution. Taste is not a mystical quality. It is the synthesis of deep technical knowledge, empathy for the end user, and a rigorous understanding of organizational constraints. As an information management professional engineer, I have observed that the most successful systems aren't those with the most features, but those with the most deliberate and intentional ones. Your taste is your unique signature in a landscape of automated uniformity. As you return to your development environments, remember that while AI can replicate patterns, it cannot replicate the wisdom of knowing which pattern to break. Your journey toward becoming a high-value strategist doesn't end here. It begins with the very first decision you make tomorrow morning. This concludes our guide to the 2026 reversal of developer value.